Hey everyone. Now I know a lot of you saw my video last week where I mentioned I was looking at moving ISPs. Well, I've done that now. I've moved to Aussie Broadband, which apparently all of their staff must have commented in my video to say do it. But anyway, I've moved to Aussie Broadband now and things are looking better. Not quite perfect. It thinks I'm in Melbourne when I'm in Brisbane, but it's better. So anyway, as part of that, I got IPv6 for the first time. Now I've never used IPv6 before. And the reason is I've never had to. Everyone's got IPv4, even in enterprise places, me at home here. So I've never had a reason to learn it. But I know it's out there and the day's going to come when we're going to have to. So I thought I'd use that opportunity by getting IPv6 from an ISP just to practice it and get used to it. So in the last couple of days, I dived right into it and set up IPv6 here on my home network. Now, I'm certainly no expert because, as I said, I've just started using it a few days ago. But I'll go through what I've got set up and the things that I've learned, because I know a lot of people even in the IT industry that I know have also not had to touch IPv6. So I'll just show you what I've learned and maybe you'll learn something too. And I might get things wrong because, as again, I'm not a guru on that. So anyway, I'll show you the setup. Now physically the setup's the same. I'm still using a Raspberry Pi as the router. I've just moved it up here since I had it turned off. I could juggle the cables a bit. But it's the same sort of thing. So everything is being routed on that Raspberry Pi there. The modem is still my lovely little SFP modem there. And the rest is the same switch, same cabling and all that. All right, so just before I reboot this router, I'm going to have a look at the uptime. And there it is. It's been soldered for a long time now. So I just thought I'd show that before I reboot it for some reason. All right, so to start with, I'll just look at the biggest difference, which is the amount of addresses. Now, IPv4 is 32 bits. Now, so there are all the bits there. That's how we represent it, you know, a group of 8 with a dot. But we put this in decimal value. You might have seen things like 192.168, 0, whatever. But ultimately, you've got 32 bits. So 2 to the power of 32, that is 2 to the power of 32, is this big number here. So it's about 4 billion. This one down here is 128 bits. So that would be 2 to the power of 128, which equals this absolutely massive, unthinkable number here. So it's the same concept though. It's just a bunch of bits as far as the computer's concerned. So you've got 128 bits instead of 32. So each bit doubles it. So where are we? You got that would have been 32 there. That would have been double IPv4 right there. But we didn't just go double. We didn't just go 4 times. We went that many times. So the way I've drawn the dots here is just in the normal notation. For IPv4, we use a dot after every octet like that. For IPv6, we stick a colon in. So that's the first bit. Now, as I said, I've set IPv6 up over the last couple of days now on my network and it's functional. But if you haven't done IPv6, you've probably still got some IPv6 running if you have a look. So I'll show you my interface on this machine right here. And first of all, I just use IP add, or it should be IP add show for IP address show, but you can just use IP add. If I want to narrow it down to just IPv6, just do IP-6 address, that'll do. So just the IPv6 stuff. So this is just this desktop here. Now these are my new ones, but just disregard those for a minute and have a look at this one here. So if I just do that again and just show the link one. This is my interface here. So there's that really big long number and it starts with FE80 and has the word link in it, or scope link. So that tells you it's just on this network segment at home here, so hosts can talk to other hosts. So you don't see the amount of numbers that I had before, because what you can do is when there's a bunch of zeros together, you can put double colons here and that just abbreviates it a bit for you. You can only do that once in this thing, because if you had a whole bunch of zeros which you abbreviate to that, you can't do it again because you wouldn't know if there was 3 packs of zeros compared to 1. You don't know, it would become ambiguous. So you just do that. So anyway, what you can see there is the last half of this would be that there, those 4 chunks of values here. So that's 64 bits of it, and the other 64 bits are here. So FE80 0000 0000 0000, then the rest of it. Okay. So what I can do, if I go to another host on my network here and do the same thing, IP-6 address show, just look at the link one. So it has an address there. So that's one of my Raspberry Pis. If I get that address back in here and just do ping that, it'll ping. It's all good and well. Now, one thing I found is if I thought, okay, I'll try to SSH that, and I just do pi at that, and it doesn't work. Okay, but what I noticed up here, when it sent that ping out, it added the interface name, and I tried it, and that's what you've got to do there. So now I can SSH the Raspberry Pi outside. So you can do this without having set up IPv6, because it's probably running already with one of those link interfaces. If I piss that off, you can see I'm connected from that IPv6 address, which again is the FE80, which is my one back here. So that link is like an APIPA address, which you might have seen something like that on a Windows machine, especially if they can't get an IP address from DHCP for IP version 4, they'll get this. And that's the same kind of thing. It's an address that's only usable on its local LAN segments, automatically generated, like the other one. Because what you might notice is that address is based off the MAC address. So my MAC address, where is it? Ends with this. And that forms part of this address. So something like that. Anyway, there's a 0 in there too, by the way, but they've abbreviated that as well. So FE380270, similar to my MAC address. So it's self-generated just for link communications. So when I joined this new ISP, they gave me a bunch of IP addresses. They gave me, obviously, that's my IPv4 address, but they gave me these couple of subnets here. And what that means is I've got my actual WAN address, which starts off with this. That's 64 bits there. And as you can see by these two columns, the rest is zeros because that's the network. That's showing me the network. So it's a /64. So it tells me that my address will start with these values here. And as it happens, I'll show you in a minute, but what it turned out to be was that. So that, as you can see, starts with the same thing that's there. And then this part really is my address. So that's the network, and that's the address. Okay, so that's good and well. That's on my WAN interface as we speak. This other bunch here, it's even more addresses. So the network portion is only 48 bits, and the rest is for me to use however I want. That's what they've given me. So going back to the amount of addresses available, I've got way more available for my own, whatever I want to do with them on my side of the network than there ever were IPv4 addresses in the world. So it's just a crazy amount of addresses. So anyway, that's what they've given me. So on my router, the good old Raspberry Pi, if I have a look, version 6, IP address show for device Ethernet 0, which is my LAN side, this is what you see. Now, you see one of those link addresses like I showed you before, the one that starts with FE880 and the rest of it. That's what I showed that ping with before to other hosts that they've all kind of got. But now I've got this one. I set this manually though. So what I did, if I go back to here, this /48, don't forget this is my internal side. So that's the WAN and that's the LAN. And that's, forget about IPv4. So the WAN one was given to me and that's what I got. And this one's here for me to do what I want with, as long as I started off with that. So what I did is I set up an address here, the same prefix at the start, and then I've put a 1 for the next bit, and then the rest is 0. So I'm kind of calling it a 1 network there. So I've made it a /64, if you know what I mean. So that would be 48 bits right there. Okay. As soon as I put a 1 after it there, that's 64 bits because that's 00. I'll type it out for you. That's 64 bits right there. So that's my network. So I've subnetted that to 64. And what I can do is have a whole bunch of these type of networks and just have a 2 network, a 3 network, a 4, all /64s. But I've just got the 1 for the moment. So that's what I'm doing there. So what I did, I picked that, and I picked FE just for the hell of it. So that's my internal address for IPv6 on a global scope. So there's my valid IP address for my LAN side. Now for my WAN, what I'm going to do for you is do a packet capture of on the router interface if0.2, which is my WAN connection, and I'm just going to do IPv6. So for that, just use etherproto 86DD. That's IPv6. So that'll show all the stuff that's IPv6 on the WAN. So my light's trying to get out, and I'll get to that. So now on that router, if I do DHCP CD Ethernet 02, we'll see what goes out there. Okay, just did some stuff. So if I go back to the packet capture, I'll just stop that. What actually happened? Well, my Raspberry Pi here, the source address, sent out this message looking for stuff. It's a multicast listener, because everything's multicast. Well, not everything. There's a hell of a lot of multicast in IPv6 because there's no broadcasts. So it sends these messages out looking for one of these router advertisements. So that came from my ISP coming back here saying, hey, there's a router there. So that's all good and well. It tells my network that there's a router there. So my computer, my router, will use the ISP's router as a route. So it did all these bits here and said, yeah, no worries, blah, blah, blah. But also there was some DHCP v6. And we can have a look at this too. I'll get to this in a minute though. I just got the capture there and we'll come back to that. So here's my router looking good. So far I've got my IP address on the WAN side. Address show device, what is it? IPv0.2. So I got that address as you just saw. It came in, actually I should show you where it actually came in. Okay, so what you saw is the router telling me where it is and my address that actually came in here, which that's a request from me because I already had it, but that's fine. And it will bitch about my name because all I've got is router. Haven't got any domain name stuff. But don't worry about that. The fact is I got my IP address from the router at the ISP. Now if I go back to my LAN side, just if0, I set that interface address here with the one that was given to me from that /48 mask from the ISP. So if you remember, I got that to choose from. So what I did, I just chose that with a network 1. I've subnetted that 48 into 64 with a 1 there and just put FE as essentially the host name that I use. So that's good and well for the router, but I need to make the router actually route. So in order to make my router actually route, it's similar to IPv4. You go to the sysctl conf file and you can see all the options in here. That's the one I had for it to be a router for IPv4. Well, there's a similar option just a bit further for IPv6. So I want this to be a router for IPv6, so I just had to uncomment that one. And sysctl-p, you can see it there. So that's what I've got forwarding on the router. So you can see I'm doing forwarding for both IPv4 and IPv6 on the router. So in my network interfaces config, now I've got a lot of config on here because I've got all those other interfaces, but I'll just start with the WAN interface. So here's my WAN. You can see all the other crap I got here for the other VLANs on IPv4. They do what they do. But anyway, for the WAN interface, for its IPv4, I've just got telling it to get DHCP address as usual. But for IPv6, I'm saying use DHCP, but there's a couple of things here. First, the accept RA. That's telling it to accept router advertisements. If you saw in that packet capture, these router ads are coming from the ISP. Basically, that says to accept them, but with a 2. So the 2 means to accept them while we're doing forwarding. So when I set this up to do IPv6 forwarding to be a router, in order to accept those RAs, I have to set that as 2 because I've made it a router. Otherwise, it would be 0 for don't accept, 1 for accept. If it was a router, normally it wouldn't accept them, but I need it to be a router and accept them, so that's why it's 2. And now the request prefix, that has to be set because if I go, where are we? Just go back to my, show my LAN address. This thing that I'm using here, which was given to me by the ISP to use, setting it up myself won't actually route. I have to request it from the ISP in order for them to start routing to me. So that's why that's why I said request prefix 1. Even though I set it manually myself here, I have to request it from the ISP. That way the ISP does routing to me from the world. So right now, if I just ping something, you can see I'm pinging Google with IPv6. Now that's on the router, but all my other hosts, like this desktop here, I want them to ping Google as well. So I can because I've set it up, and I'll show you how I did this. So even though I've told the router to be a router, I still have to tell this host here to get some global addresses, because it can't use the link address because it won't leave the network, it won't route anywhere. So I've got to use these global ones, but I don't set these manually. I didn't make this number up. I did make the subnet, if you recall. So I'll tell you where that came from. I don't have a DHCP server in the traditional sense like IPv4, but what I've got is a router advertisement daemon, similar to how the ISP sends out router advertisements for me, like all these things. I have to do that on the LAN side of my router for my internal network. So there's a program called RADVD, router advertisement daemon. And in here, it's very simple. Just tell it which interface to serve on. I told it the prefix, which I made. That's my subnet there, /64, and it just sends router ads out, and that's it. So there's a lot of them going around the network. So when a host here on my network sees them, it goes, oh, okay, I can assign a value, and that will give them a value as part of that subnet. They will then hit the router as their gateway. The router will route because I set it to route, and I asked for that option from the ISP. And if I go back to the router here, I can now show you that this prefix address, that's the one I used, that's getting the ISP to route to me. Now, I already had this link up when I just did that ran DHCP CD before, but you get the idea. You have to tell the ISP that you want to do that, even though that's what's been assigned to me from the ISP. Anyway, hope that made sense. So that's that. I can now ping, as I said, whatever. Some things will be 6, some won't be, so YouTube is probably a very similar address. If I ping something way different, like, what's different? Twitter.com? See, it goes for IPv4. So I guess it didn't like IPv6 for Twitter. So that comes back to the DNS server, and I'm just using Pi-hole still for my DNS server. I haven't actually changed that. But you get the idea. I can ping whatever now. So what I did then is I went to the router and did a packet capture. So this is doing packet captures on my router. Same sort of thing. Interface if0.2, which is my WAN. Ether proto hex 86DD. And do the same thing, ICMPv6. Now when I ping the outside world, what I see are the pings going out of my WAN interface. And what I see though, now I'm pinging that from this desktop here. I would have expected my source IP address to be one of these addresses here, right? Either that or that, the 243 blah, 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 blah. But what happened, this address here, this source address, that's my WAN address on my router. Now, we don't, as far as I know, have NAT with IPv6, so I don't know why my source address is the WAN side of my router like it would be on the old IPv4 with NATing. So I don't know why it actually changed that. I would have expected the real one, so I still haven't got my internal one out in the net. So, but what I might do is, there's my internal address, or one of them, there's a couple, and I don't know the difference between this temporary dynamic and dynamic blah, blah, blah. I don't know because I'm new at this. So I'll try and ping that from the outside world, and I'm not actually seeing anything hit my my router. So I don't know if that knows how to get there or not. Oh, there it is. So if that's the ISP's ping there. So I just ping from outside world. So I could see that the ISP knew to send that to me. Okay, so it sent it to me. You can see the pings coming in. I didn't respond because I have the firewall blocking it. Okay, because there's no NAT, you can't even use that as a pretend firewall. You've really got to be firewalled off. So, oh, there's another random RA just comes from the ISP. So I'll go onto the firewall now and show you how I've got a bit of that set up. I won't go through the whole thing though. So here's a little part of my firewall, the important part for this bit. I'm not showing the whole thing, just this. There is more. But anyway, the table type is INET. That covers IPv4 and IPv6. Now previously, I just had IP there, but INET covers both. So my policy should probably be dropped, but it doesn't matter because I've got a default drop at the end. So this is my interface name, which is my WAN interface. So what I'm letting here is, most of this is similar, by the way. I haven't changed much of this. I've just added to it. So this is my connection state established or related, accept. That's just there to allow my return traffic. So when I pinged out from this desktop, that associated ping reply could come back in, as you'd expect. That's pretty standard. The other one here is just a standard UDP destination port for OpenVPN. Another one, now this UDP destination port 546, I'll show you what that is. I did a packet capture of it. So every now and again, the ISP will send this advertise out there, which has my prefix delegation, has all the stuff for my subnets that I'm allowed to use. And if I don't respond to that, so it's sort of, think of it like an offer if you want, or advertisement, and then I have to respond and say, yeah, give me those. Okay, so I ask for them and I say, yep, give me those from my WAN address and give me all the other things and blah, blah, blah. If I had that blocked, I wouldn't respond to this. So that would come in, as you can see, that's UDP destination port 546. So I needed a rule to allow that in so that I could then request my my subnets. Because if I didn't do that, the whole thing would stop. So that has to be alive. So that's the reason that's there. And the others are just some IPv6 packets to enable the whole thing to work. So router, solicit, advertise, neighbors. Oh, it doesn't necessarily have to be a router. It could also be neighbors telling what's around as well. So I let that in, and that's only going to come from the ISP's router. And everything else drop. So that's all pretty bog standard. It's just letting a couple of things in for the IPv6 to work, and as usual, drop everything else. So if anything comes in that's not that, it's not going to get through the firewall. That's it. End of story. Now leaving my firewall is a different story. So all these seemingly random addresses that I've got on my network, like I didn't put all this in manually, it was just kind of done for me. And the same as if I go to my SDR receiver, for instance, and show its IP addresses, it's also got some stuff here with that subnet. They were given from my router, remember, from that RA-DVD program. I don't know what they are, so I've got to figure out DNS if I want to actually use those internally. But at the moment, anything with an IPv6 address on my home network that tries to go out to the world, like any of these things, they're going to be able to. Now, as you know, I've got a whole lot of these so-called smart light bulbs, which I block. In IPv4, I just block their IP addresses from going out into the real world. But I don't want them going out there just because I'm on IPv6. Now, as it happens, in my Aruba controller that I have, I've got IPv6 disabled. So none of my wireless clients actually have IPv6 because I've disabled it there. But how I plan to firewall those, if I put them on IPv6, is at the Aruba controller, because I won't be filtering it by IP address. I'll be filtering it by the user. So every wireless client is a user on the controller, and I can just say what that user is allowed. So it's a closer firewall to where the actual wireless client is anyway. I'd have to figure out, as I haven't yet, how to stop IPv6 traffic going out for specific hosts that I don't really know their IP addresses. Really, that could be anything. So that's that. Now, one thing I noticed from the ISP was when I was doing my IPv4 DHCP, I do the discover from, just nothing to ask for anything. I get the offer. Now I got offered this blah, blah, blah .16. And then when I request it down here, I get negative. I get a negative acknowledgement. It's like, no, you can't have it. So then I got stuck doing this over and over and over. The Raspberry Pi did. So I'm just trying to get an IP address, and it didn't work for ages and ages until finally it did. Now, I find that kind of bizarre because, like, I'm trying to request the address that they offered me anyway. Okay, so that to me looks like a misconfiguration on their DHCP server. It doesn't seem normal to do that. And the only thing I could possibly maybe put it down to is some sort of flood mitigation, but it doesn't make sense because it's already servicing that particular DHCP transaction anyway, and it did offer it. So I think that's bad. I might have to get some finer details of that and put it to them to sort out. But anyway, it causes a problem when I was doing lots of reboots of the Raspberry Pi as I was trying to figure out all the other IPv6 stuff, and it would get stuck on the boot up at the bringing up the network part, and then that bit would fail. So it was due to this, which is a bit of a pain. So Aussie Broadband could do to sort that out. So just going back to my router, this time on the LAN interface, I've got the static IPv4 like I always did, but I've just added the IPv6 part like that. So I've used part of that subnet that was assigned to me, and I've subnetted it there with a 1 for the next bit, and just an FE on the end, and told it the net mask is 64. So I probably could have done a /64 actually. But it's just a matter of piecing together all the bits of info from around the net, which was a pain, but I managed to get it going. Okay, so there you go. I've changed ISP and I've now got IPv6 to play with. Now, everything you saw me just do may or may not be right, might not be the best way to do it, but I did only just start a few days ago. So from having really no IPv6 knowledge to getting the system up and running, I think is not too bad. Now, the reason I still use the Raspberry Pi as my router, even though there's probably other systems out there that do half of that for you, is because I want to learn it. I want to know how the Linux box thinks. I want to know what's required, and I want full control over it. But the main reason, the biggest advantage of that, is that I can run packet captures on any interface I want on the Raspberry Pi. So as you saw, when I was running Wireshark, that was actually TCP dump on the Raspberry Pi being piped back to Wireshark displayed locally on the desktop. So things like that. Now, as I said, I'd like it if the ISP fixed up that DHCP4 issue, because that causes a bit of havoc. But generally it's working. The big things I've got to look at is DNS. I haven't done that yet because I can't use big long addresses like that for my hosts around the house. I have to sort DNS out. And the firewall's sorted, but the firewall to stop things going outbound would still be a problem. I haven't really thought about that much, but I don't need to, because the ones that I want to block are these wireless devices, all these lights and things, and I've got them blocked at the Aruba controller. So that's my Aruba controller in there, and I can just block them by user role. So when they join the wireless network, they're given a role, and I can have rules for that role. So that's some fine control there. So anyway, that's where I am at the moment, and I'm sure in the future I'll do more on IPv6 because that's what I want to do. So got to keep up to date somehow. Anyway, that'll do. Till next time, take it easy.